Good evening, sir.
Good evening, Gaurvi. Kinematics of particle 3. Until now, we were defining the meaning of the words kinematics particle. All right.
Yes, sir.
Now, what actually we do? Of course, kinematics is the study of motion without reference to force, we mentioned. But what actually in this lesson we do for both the subject requirements and as well the exam requirements? Look, we find out, or we find out, we can say, we find out one, position; two, path; three, velocity; four, acceleration of a particle as functions of time. Most of the times we do this. For this, we've got two methods. If position is given, what do you mean by position is given, children? We need to, I told you already, talk in a mathematical sense all the time. That is, this r bar is given. That is a position vector. Particle moves like this. Okay. This will be r bar, this will be r1 bar, this will be r2 bar, like this. This is what you mean by position is given. Everybody knows here, isn't it? The position of a particle can be described by a position vector. Once the position is given, that means once r bar is given, we followed the method of differentiation. We follow the method of differentiation to get what? Velocity and acceleration. But if acceleration is given, for example, I'll just go to the next screen. If a bar is given as function of time, by the method of integration, we get what? Velocity v bar and position r bar. Actually, I'm using the word position alone, but actually this is position vector. I told you already, though in physics we make many statements, finally, what is the mathematics of it is the main idea. Okay. So Differentiation and integration are very important for this lesson, is the main message I wanted to convey. So for a particle, we do all, and of course, let me ask you, what is path of a particle? What do you mean by, or what is path of a particle? Okay, the way I put the question, you say, what is path? Path is the path followed by the particle, isn't it? Or let me say, how to find the path of the particle, how to express path of the particle, how to express path of the particle in mathematical form. This could have been the question, not just what is path of a particle. Look, if a body is moving in a two-dimensional plane, for example, we'll take a coordinate system xy and find out a relation between x and y. Say it is the algebraic relation between x, y, z coordinates. So for example, if v is there, I'll find out position from that by the method of integration. Look, r2v v2a, this is by differentiation, that is dr by dt, dv by dt, like that. If a is there, a2v v2r, it is by method of integration. We'll show it. Once you know r, you know x and y, because isn't it so? Between x, y, z coordinates, like r will be written as what? Some 2t I cap plus, for example, 2t I cap plus some 5t square j cap I have, for example, position as a function of time. What is x here? X equals 2t, right? And y equals 5t square. So put t equals x by 2 here, x square by 4 square. Do you understand? X equals 2t here, y equals 2t square. T equals x by 2. I put it here and squared it. So I'll get y equals 5 by 16 x square. This is a parabola equation, children. So this kind of a thing is what we call path. Hope you followed this. So that will give some parabola there. So finally, what does it mean? It means that, just give me 1 second, I'll just change the cell. So tell me, what do we do in kinematics is all this. We'll find the position, we'll find the velocity, we'll find the acceleration. But basically, most of the times our method is to find them out as functions of time. How these things change on time is what we calculate. Any questions, children, meanwhile? Not only that, we'll also find out the relation between these quantities, position, velocity, acceleration of different particles. I hope people followed this. Any time in future, when are asked to find out the path, and if they gave you this x and y in terms of time, simply eliminate t from that, you get the path of the particle. So path, velocity, path, position, velocity, acceleration are the quantities we deal with in kinematics and nothing else. Okay. Any questions, Ria?
No, sir.
Right. Now, we'll also find out the relation between the position, velocity, acceleration of two or more particles. This is what all the sums in kinematics do. By talking in general terms like this, I have told you at one go as to what we are all going to do in kinematics practically. If at all you would like to know one example, I'll show you that. What it means to say the connection between the velocities of particles. Look, there is a light pole giving light. A person walks. Okay. He's walking like this. If he's walking with a speed v, for example, the heights of the things are given here. This is height h, his height is h. With what speed does the tip of his shadow move? This is what you mean by connecting the velocities of different particles. Look, I'm saying particle, but we are dealing with the person. Okay. How do we do this, children? You know, shadow forms like this. I'll just draw another figure. This is the problem figure. I don't want to spoil it. But I'll just simply show you a line diagram. This is my height of the pole. This is, see, shadow will be formed because light goes in straight lines, and this is the height of the person. All right. So my job is to calculate, and this will be the tip of the shadow, right? Do you agree? Shadow will be formed like this.
Yes, sir.
Right?
Yes.
So now with what speed does this travel as the person moves like that with v is our question. And we know very well the speed at any instant is called instantaneous speed, and it is simply the rate of change of x position. So could you tell me, could somebody suggest me as to what to do in this? What do I need to find out? I need to find out with what rate this coordinate, I'll take my origin here, O, for the coordinates. So with what speed does this coordinate change? This coordinate you can call, for example, is x1. This you can call as x2. I was given that from the problem v equals dx1 by dt. Are you all okay with this? So all of you have taught this. Not
Yes.
at, of course, the differentiation, you can go back to differentiation and see. I'll try to put some videos on differentiation also, the outsiders. So v equals dx1 by dt, all right? I should know what is v1. We know v equals dx1 by dt. Is it all right, children?
Yes, sir.
Yes, sir.
Pavani, Sudesh. Sudesh,
Yes,
are you attending classes every day? Sudesh? Huh? I don't know. You're not speaking. Payosni, yesterday you were not there, I believe. Payosni, you should be very regular. Remember, if you're very regular, two things will happen. First is the culture of learning physics rubs in. Without making any special effort, if you're open to ideas and if you like this kind of learning, you automatically start thinking that way. So your job of reading textbooks, guidebooks will go, because every day we are talking the same thing again and again. And second thing, in the beginning, if the continuity is missed, it is difficult to catch up later. So you need to keep coming every day. Now, what do I do, children, for this? Anybody can suggest something? I've told you x1 is this. This x1 is the instantaneous position of the particle. Is it all right? And instantaneous velocity is what, children? The rate of change of that position, right? I want your feedback. Is it okay, children? We know V is dx1 by t, v1 equals how much, is all right or not? Gauravi, are you there today?
Yes, sir.
Is this okay for you?
Yes, sir.
Right. How about you, Payosni? Why don't you speak once? Listen to your voice. Payosni Parag Joshi. Tell me. Okay, she's not speaking. She or he? She only. Payosni is she.
Yes, sir.
Then if you don't speak, I won't be knowing whether you're a girl or a boy, right? Okay, right. Now look at this. Now, rest is all connecting H, X to all this. So can I write something like this, children? Like, for example, if I say this angle is theta, what is tan theta in the bigger triangle?
X by x2.
Or you can use as well the properties of similar triangles. Tan theta is what? H by,
H
by
2.
2.
which is also equal to what?
H by x2 minus x1.
Small h
X2
by
minus x1.
x2 minus
x2 minus x1.
That's all. So rest is just to differentiate. The space is not enough. I'll just write by the side, but don't get confused with the whole thing. So cross multiply to make it look simple. H into x2 minus x1 is equal to h into x2. I want to bring x2 one side, x1 on the other side. So what will I get, children, here? hx2 minus
Yes.
hx2 is equal to h x1.
x1.
So h minus h into x2 is equal to h into x1. So what is that I should do now? Differentiate. H and h are constant, children. So h minus h into dx2 by dt is equal to h into
dx1 by dt.
Now we know dx1 by dt is v. This is what? v1. Isn't it?
v1.
v1 equals h by h minus h into dx1 by dt is v. So this is what you mean by connecting the velocities of two particles here. So we've used geometry there. So that's what you mean by connecting the velocities of different particles. There are, in vectors also, people have done it. Velocity of one particle with respect to the other particle, all that. Or three particles are moving in towards each other from the vertex of a triangle. Where do they converge? So it's all trying to connect the relationship between velocities, accelerations, positions of various particles. So one particle and various particles. But for all these things, what we do simply is find out the velocities, accelerations, and displacements, distances, all that. Okay? Is it all right, children?
Sir.
Yes,
Yes,
sir.
sir.
Yes.
So can I go to the next slide?
Sir.
Yes, sir.
Right.
Yes, sir.
But of course, at a later stage of our course, even at this elementary level, elementary in terms of ideas like this problem will make the problem little challenging. Physics, actually, the ideas, first of all, you should catch, but remember the application is equally important. You do that in a very evolutionary and natural way, not try to imitate somebody by just directly going to some big problem and feeling happy that we did big problems. As I keep telling all the time, one day you have to do problems on your own, and you should be doing better than I did or better than I do. So a teacher's day is done when his or her students do things from what the teacher has taught them, but do it quickly and better than their teacher. Remember it. All right. Now, I'll continue. So that's what we're going to do in kinematics. But to do that, we require to have equations of motion in kinematics. We already know Galileo gave us V equals AT or KT and S equals some other constant, for example, some K1 T square like that. He already has given us. But we'll make it more elaborate and more detailed. But I want to just go from your 10th to 11th. So I won't do the heavy duty maths in the beginning. I'll just put a heading now. Equations of motion. Actually, this is a specific case we're discussing deliberately. Equations of motion. Equations of motion in a straight line with a constant acceleration. The straight line and constant acceleration are special cases. With a constant acceleration. This is known to you, so I'm just trying to develop from there. We'll make it more general as we keep doing things. But what are the equations of motion? I'll mention first. I'll be writing without vector sign, right? Because I already decided that the motion is along a straight line, like this. Maybe some origin here we put, and we think the body is moving, right? So for this, we'll write many equations. The equations are even if you knew them, see, I'll always add something better and new. So keep your eyes and ears open. 1. V equals U plus AT. No vector signs I put. The moment you put vector sign, it becomes a generalized equation, children. That will be applicable even in 3 dimensions. But here, the way I wrote it, it is in 1 dimension, just like this. And it is our usual practice to call this V as final velocity, U as initial velocity. Whereas I would call it velocity as a function of time. Initial is all right. Initial velocity has to be given that name only, but there's nothing like a final velocity. Instead, you can say it is instantaneous velocity. What is it? Instantaneous velocity. Why do you call it instantaneous velocity, children? This is V equals U plus AT. So different values of t will give you different velocities, different instances. Therefore, I should call it V as a function of time or V instantaneous, not just final velocity. Do you understand? Huh?
Yes.
Yes, sir.
This is instantaneous or V as a function of time. Second equation is S equals, I'll write it in 3 ways. U plus V by 2 into T or r s equals, sorry, r s equals ut plus half a t square, or s equals vt minus half a t square. Srihit. In all the cases, don't think because I put a minus sign, this is deceleration here. This is the main thing. Remember, the condition under which it works is only this one. What? Constant acceleration. True only in the case of constant acceleration. That means initial plus final by 2 into t, you can write only if the velocity is constant. All these things I'll be proving. Huh? But now in this u plus v by 2, you put v equals u plus at, you will get this equation. You put u equals v minus at, you will get this equation. That means sometimes you can, in a given problem, if v is given, that is easy to apply this equation. All right?
Yes.
This formula, because I wrote a minus sign, never think this is deceleration. It is acceleration only. Okay? Of course, I'll tell you what is accelerated motion in pure visual terms slowly. I told you already, I would like to take you from what you learned in 10th and what you keep learning here and there. Because if I start at the top, probably there will be a mismatch between what you've been learning and what you're going to learn now. Okay, so these are the three ways you can write the displacement equation. Third one is v square minus u square is equal to 2as. And fourth one will be s nth distance displacement covered during nth second, that is u plus a into n minus half. These are the equations of motion which help you solve hundreds of problems in a straight line. A very specific case we took, but remember that is in terms of application, that is going to be the most challenging one and within the syllabus. And it will be fun doing problems based on these equations. All right. I'll be deriving them also the way you derived it in 10th class or 9th class or even in 11th class. People do only this and leave it. Don't go for more generalization from integration and all that. That also will take care. I want you to get into problem solving mode slowly. Okay. Now, before deriving these equations, I would like to just know from you. I'll define every word. Believe me, I've not started the way I should start at 11th yet. I'll be defining words, everything. Right now, whatever meaning you attach to these things, that is still okay for me. Right? Now, look at this. What is uniformly accelerated motion, children? I'll just show that in visual terms I told you. Look. First of all, uniform motion. What is it? I'll show you. The body continues to be in the state of rest or uniform motion. Don't we say in our Newton's first law? Huh?
Yes, sir.
Yes, sir.
The word used in
Yes,
Newton's first law, I'll mention here. The word used in Newton's first law. What it means is this. The body should go in a straight line. We should not change the direction. Maybe you start here. This is t equals 0. The body starts moving from here. Let me see. First thing is that it should move in a straight line. If it is deviating from straight line, its direction is changing. If the direction changes, there is an acceleration. Do you follow? So uniform motion is one which is not having any acceleration business there. So now, say this distance was some 100 meters. All this took place in 10 seconds, let me say. Now divide this time into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rather. I don't know whether it became 10. First, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10. But it's not 10 seconds over anyway. Just a minute. Right. Now, remember, if it is 100 meters completely, it should be 10 meters here, 10 meters here, like that. In every 1 second, it should be what? 10 meters. Now divide this 10 meters into, now 1 second we told, no? Make it into equal intervals of 1/10 of a second. So in every 1/10, how much distance should be covered? Tell me. 1 meter.
1 meter.
Like that, you make this into 1/100th of a second. In every 100th of a second, the distance covered should be 1/10.
1/10.
In all the, we made it into 10 intervals here. We'll make it into 100 intervals. We make it into 1000 intervals. In each equal time interval, the distance must be same. Then you call it uniform motion. That's what you mean by saying that in mathematical terms. You should say that ds by dt is what? Constant. You know what is ds, children? Infinitesimally small displacement. This is infinitesimally small time. So in every infinitesimally small equal time interval, the ds must be same. Then you call it a constant velocity or a uniform motion. Do you follow this?
Yes, sir.
Any objections for this?
No.
No. Right. In a similar way, no, my point is this one. If any time in physics, especially in mechanics, and even in more so in kinematics, if you could reduce everything into space and time, if you could imagine a situation in terms of the space and the time, then you followed it. That's what you mean by visualization. So for me, this is a constant velocity case. You can take uniform motion, we can say. The speed should remain constant. The direction should also remain constant. Then you call it uniform motion. So when I close my eyes, I'll be thinking like this. Okay, the body is moving. In every 1 second is going 10. In every 1/10 seconds is going 1 meter. In every 1/100th of a second is going 1/10th of a meter. Like that, I'll be imagining in myself about that space covered in a particular time. So visualization is that. Bring everything down to that space and time, and then you can say that you could visualize the whole situation. Okay. Even if it turns like this, remember, it's an acceleration case. What is it? Acceleration case. Direction, speed can remain changed. It can be 10 here, it can be 10 there, but still it's not a uniform motion. Do you follow this? Because the direction is changed, and it means there is an acceleration. Okay. So that acceleration motion can be only a deflecting motion where the speed can be there, speed can be constant, but direction alone changes. All right. The moment the body turns, remember that there's a force acting. Otherwise, it wouldn't turn. That's what the essence of Newton's first law, basically. A body continues to be in a state of rest or uniform motion along a straight line unless and until external force acts, right? So what is uniform motion? The way I showed it here. All right. Now I'll continue, children. What is constant acceleration or uniform acceleration? Look, you will simply say it is the rate of change of velocity, will say dv by dt, all that will say, but I would like to visualize it for you here. Say you started from rest, del variable u equals 0, I'll put. In 1 second, you'll cover some distance, probably 2 meters. In the next second, you should cover 6 meters. This is 6. In the next thing, you'll cover 10 meters. That means the ratio must be 1:3:5. In the successive seconds. This is in the first second. This is in the next second, next 1 second. This is in the next 1 second. So this kind of a motion, if it is happening, you call it constant acceleration. If you know what is this, if you are worried about how you showed this, once again the equation only. S equals 0 plus 0 into t plus half at square, right? Huh? So S equals, you get half at square. Though Galileo showed it for freely falling bodies with constant g, that can be applied on the ground with constant acceleration also. We'll be showing that now. The derivations also I'll show. Now, for example, a equals 2, children. Now a equals 4, say. So what will be S in 1 second? Half into 4 into 1 square. How much is it? 2. S in 2 seconds, full 2 seconds will be how much, children? Half into 4 into 4. How much is this? 2 square is 4, isn't it? So how much is this, children? 8. So look, from here to here 2, from here to here 8. So just here it is 6. Do you follow? This whole thing is 8. 8 minus 2 is 6.
Yes, sir.
In the next second. And similarly, S in 3 seconds you calculate. Will be how much? Half into 2 into 9.
80.
It is 3 square, isn't it? Half 4 into 9, sorry. A is 4 by 2, right?
Yeah, 80.
3 square, isn't it so? So this is how much? 18. So 18 minus 8. How much is that?
10.
10.
So that means this is the way you will visualize uniformly accelerated motion. Of course, here I put it u equals 0. If u is not 0, slightly different things come. So anytime, because many times I feel somewhat disappointed with students and teachers. Use acceleration, velocity, everything mixing up. You understand? The words have their unique, very well-defined meanings. Try to understand. You cannot use them indiscriminately, confusing one with the other. I've seen people say a body is moving with a lot of force, people say. Can you say that? No. Force will be acting on the body. You cannot say body is moving with lot of force. Body is moving with great velocity, you can say. Isn't it? So that's the reason why I was trying to tell you, come on, stop, mute your audio, Tulusivardhan. If there are people in your room talking, it is a compulsory that you need to mute your audios. You cannot disturb others. Right? Tell me, children. So this is the meaning of uniformly accelerate motion in straight line. So for this, we are deriving the equations. All right. So the first equation. You will start like this. Say a body, in fact, this is a particle, starts with an initial velocity u and moves along a straight line with a constant acceleration. Why I wrote this so many details is these are what are there in the question. Find the velocity as a function of time. In other words, find the final velocity. Find the velocity at a time t. Okay. Since A is given to us, from A we'll calculate V. So we know we are given A. We know A equals V minus U by T. It's not a good way to write, but remember, we could do this here because A is constant. What do I mean by that? A equals delta V by delta T is the definition of average acceleration, right? And A instantaneous is dV by dt. Since A is constant, both are going to be same. I want your feedback immediately. Therefore, I can get away by writing A instantaneous equals V minus U by T, because this moving with a constant acceleration means he's giving you the instantaneous acceleration. So I can just write like that. So V minus U equals AT and V equals U plus AT. So this is the one I'm adding to your existing knowledge. Here, if A is constant, I don't know whether people understood. The way I wrote V minus U by T is, I'm writing average velocity, right? But I'm
Yes, sir.
equal to instantaneous because they are same. If A is constant, A average is equal to A instantaneous. Tell me, children. I'll once again define all these things and talk more of average acceleration. In differentiation we talked, delta y by delta x we talked, dy by dx we talked in mathematics already. But right now I'm just starting from a bottom-up approach for a while. A specific case of a constant acceleration and straight line we took. And we know A is change in velocity by change in time. But there's no single acceleration. There are two accelerations. If the delta t is a finite one, it is average. If the delta t is going towards zero, it is instantaneous. Okay. Since A is constant, they have become one and same. Therefore, I could write A equals V minus U by T and cross multiply and do that. So that's the way you need to define the first, derive the first equation. And I'm waiting for your feedback. Come on, tell me. Bhuwana.
Yes, sir.
All right.
Yes, sir.
Payosni. Payosni, are you in 10th or 11th?
Sir, I am.
Huh? You are in 10th class or in 11th class?
I am in
I'm not able to hear you. Are you in 10th
sir,
or 11th? Huh?
sir, 10th class.
10th.
I am in 10th class.
Right. So this will be very much useful to you, the way I'm talking now. Huh?
Yes, sir.
Are you following?
Yes, sir.
You are in CBSE stream or state syllabus?
CBSE, sir.
So medium is English only, not semi-English and Marathi, right?
Yes, sir.
Okay. So have you followed this?
You have attained orders.
Payosni, I'm not able to hear you. The voice is not coming properly. Okay. Let us talk later. Then, can I continue, children?
Yes, sir.
Okay.
Yes, sir.
Right. But this can also be derived from the graph. Look at this. A velocity time graph, if I take, since it is having an initial velocity there, the graph will start like this and go like that. Isn't it? Anytime you have, for every equal change in time interval, velocity changing equally, you'll get a straight line. What we told previously in algebraic terms is shown mathematically like this. Slope of this line will be, this is theta, for example. If this is initial velocity, this v is on the y-axis, time is on the x-axis. So at a time t, if you think it is v, this will be how much, children? Delta y, isn't it? y2 minus y1. This is how much? T minus 0. So tan theta equals v minus u by t equals acceleration a. This is a average actually, but in this case is also a instantaneous, which we simply call it a. This part was done to all of you. Delta y by delta x. So here a equals v minus u by t, at equals v minus u, and therefore v equals u plus at. Right? But that is algebra, this is geometry. But I can get this equation just by my counting calculations. Look at this. If it is starting from here, why am I doing in so many terms? Just by listening to this, things should settle in the mind. If you are thinking kind of a child who wouldn't want to mug up things or who wouldn't want only logic, mathematical logic is good. Sriya and Sriya, mathematically that logic is good, but what is it telling in physics is very, very important. Look at this. U equals 0. After 1 second, if there is acceleration like that, what will be the velocity? What is velocity basically? What is acceleration basically? Change in velocity per second, right?
Yes, sir.
So if it is u and a is a change in velocity per second, at the end of 1 second it will be a, right? Velocity. At the end of 2 seconds it is, tell me, 2a.
Yes, sir.
At the end of 3 seconds it is 3a. U equals not 0, u equals something there. So it is u plus 1. This is u plus 2a. After some time it is u plus 3a. After t, it is u plus at.
Yes, sir.
That's a simple way of understanding it. A is change in velocity by time when you write. A is that is changing velocity per second only, isn't it so? Harihara Vignesh?
Yes, sir.
I really want you to understand equations in a proper way, not in a blind way. This part, whatever I talked, did you follow, Vignesh?
Yes, sir.
Acceleration is change in velocity for every 1 second.
Yes, sir.
Acceleration is change in velocity in every 1 second. So at every 1 second, the velocity increases by A. Am I right?
Yes, sir.
Isn't
Yes,
it?
sir.
So it's so simple that way. Of course, the constant acceleration. After 1 more second also the acceleration is A. After 1 more second also the acceleration is A. So after t seconds, you'll add t into A for initial velocity. That's how the velocity changed because of the acceleration.
Yes, sir.
Is it all right, children? So just V equals U plus AT, I just went on elaborating this way, that way, this way, that way. So can I continue?
Yes, sir.
All right. So finally, of course, yes, there's one more thing here. Let me finish it off that. Here we said A is acceleration, but we also use the word deceleration, for example. In that case, what happens? Initially, if it covers some distance here, later it covers lesser distance, lesser distance, lesser distance, lesser distance, and stops. In which case I can write V equals U minus AT or plus minus A into T. You know, deceleration will happen in this kind of a case. Like as you go progressively, the displacements covered will be decreasing like that. Here, the motion velocity is this way, the acceleration is this way. Here, the motion is this way, that is, motion means velocity basically. Velocity or motion. Here, velocity will be this way, motion, and acceleration also is this way. Whereas here A is opposing it. All right, children?
Yes, sir.
Right. Now, I'll go for the second equation.
Yes, sir.
Now, once again, the same wording will be valid here. What kind of a wording? A body starts with initial velocity U and moves with a constant acceleration A along a straight line. Find displacement S as a function of time. And remember, if the acceleration is constant, displacement will be U plus V by 2 into T. The actual way I'll show these derivations is from integration. I'll show that later. I could have told that directly, but I just don't want that because I want the continuity in change. I want there should be continuity. Like you should not get confused with various things. Okay. See, our formula for displacement, average velocity will be like this. V average. I'm removing the vector signs here because I'm dealing only with a straight line. So V average equals, what can I write? Delta S by delta T, isn't it? Huh? So if I take my origin to be at s equals 0, so after a time t, if it covered s, delta s will be how much, children? S minus 0. Huh? And here t equals 0 if I take, if this is time is t, this is t minus 0. That's what I mean by s by t we write. But it's not s by t, s2 minus s1 by t2 minus t1. And deliberately I've taken t equals 0, s equals 0 like this. I could have taken s equals s1 also there. That means I could have taken my origin somewhere here and measured my displacement from there, but time from here. Even that's possible. That's why s2 minus s1 by t2 minus t1 is the most generalized way. So finally, what do I get here? S equals V average into time. Isn't it so? If A is constant, see, average is actually displacement by time, children. Try to understand. But if A is constant, later we'll show that V average will be U plus V by 2. Initial velocity plus final velocity by time. This will be proved later. Mathematically, we'll provide a proof for that. Therefore, S equals simply U plus V by 2 into T. So in this shape itself, I can use this formula many times. I'll show you problems. Now, put V equals U plus AT. What do I get? S equals U plus AT by 2 into T. Right? UT 2UT plus AT square by 2. All right. But substitute what? U equals V minus AT. If I do that, S will be V minus AT plus V into T by 2. Isn't it? So this will be Vt minus half AT square. This way, this way, this way. All the three ways directly, we can use them in problems. Children, is it okay for you?
Yes, sir.
Yes, sir.
Sir.
Yes, sir, it is okay.
Right.
Yes, sir.
So just do the whole derivations in the beginning. By proof, everything should be done. This much luxury you won't be having later when the exams keep approaching. But remember, this will be a solid kind of a foundation. For everything, you know the reason. You will never apply anything blindly. And everything you will be able to connect it to a physical event. You will be able to visualize. So slowly that capacity of you as a student will keep increasing. Okay. I'll take a little more time and prove the third one also in a simple way, the way you did it in lower classes. So any questions, children? Here, I told you this I'll be proving later. Huh? Remember, anyway, it will come automatically. But as I told you, let me go from what we know and then unknown. Then the third equation. Right? How do I give the third equation? I'll use the first two equations. We know V equals U plus AT. So V minus U equals AT. We also know U plus V by 2 into T equals S. So V plus U equals 2S by T. 1 multiplied by 2. V minus u into V plus u is AT into 2s by t. This also is a very simplified way of doing things, but I'll go for integration and show it in a proper way later. Not a bad idea. Don't worry. It will be okay. Even if you do like this for the board exams, chalega. Now, I'll just I'll do the last equation tomorrow. Day after tomorrow we'll do. Tomorrow is a Independence Day, so if we conduct classes, people will be angry. So Sunday we'll have the class. Don't forget. All right, children. Is it okay for you?
Yes.
Yes, sir.
Yes, sir.
Yes. This. Some comments I'll do about the equations. V equals u plus AT doesn't have S. Just a minute. V is a function of time. Then S equals u plus V by 2 into t. No A in this, right? And ut plus half AT square. No V. Right? Vt minus half AT square. No u. And V square minus u square equals 2as. No t. Why I just mentioned like things like this, you tell me? I told you my goal is that even if you're not very good at problem solving, I'll get you into that if you just follow my rules at least. Understanding is the best one. Yes, it should have been like this. What else it could have been is the best feeling you get when you understand. But sometimes physics, some people don't like somehow, whatever reason. There are rules, proper rules given by proper teachers. In the beginning, you apply them, slowly you'll get into the correct mode for physics. So here, why did I mention like this? I want you to look at things more closely. In a particular equation, certain things will be given there. In particular problem, certain data will be given there. You have to find out, for example, here S equals Vt. Initial velocity was not final velocity was becoming 0, for example, somewhere. So using S equals Vt minus half AT square will be easier to get your time, isn't it? So you should be able to play with these equations. That's the reason I mentioned what is the speciality of each equation. The first one, there's no S. Second one, there's no A. In the third one, there is no V. In the fourth one, there is no U. In the last one, there's no T. So that's how we bring in our equations and get into the mood for problem solving. Okay, children, for today,
Yes.
we'll close the session and we'll meet once again on Sunday. This class will be there on Sunday. Sri and others.
Okay, sir.
Okay, sir.
Don't forget it. We may not put it in the timetable, but
At one time, sir.
all right.
Thank you, sir.
Sir, at what time,
Timings
sir?
on sir.
Same time. Same time.
Okay, sir.
Okay, sir.
Unless I tell you, don't change.
Okay, sir.
All right. For now,
Thank you, sir.
session.
Thank you, sir.
You all followed.
Thank you, sir.
Aditya, and others. Okay, children. Bye.
Followed, sir.
Thank you, sir.